In this video course, we're going to cover how to model the Philips Pavilion by Le Corbusier and Lannis Xenakis. And I'm also going to go into a little bit of the history of the actual design of the pavilion. I'm no expert on it, but there's a lot of great documentation, and I will share that documentation with you throughout the course. This is great for beginners and intermediate users of Rhino. I'm not going to go into complete detail of how to model it exactly, but to get the general massing, that's what I want to cover, and some quick tricks that you can use in Rhino that may make it look parametric, even though it's like fully done in Rhino. So let's go ahead and get started. So the first thing that we need to do is have some kind of documentation. And the beautiful thing about this project is that it's actually very straightforward because the actual construction of the project needed to be straightforward given the complexity of the form. And so what we have here is a very general plan and a general elevation. And these were taken from a lot of documentation that you can find online for free. It's public. This one, I think, was taken from the Polytechnical University of Milan, and these are the people who actually drew them. But if you just type it in online, you'll find these floor plans and elevations and sections everywhere. But these are the ones that I use that I found useful. So the first thing that I want to do is make sure things are to scale, right? So right now, I am in feet. If you look down here, I'm in feet. But these are in meters right now, and which is okay. In Rhino, you can type in meters and feet. So I want to make sure this is to scale. So what I'm going to do is let me just click on this image here. Let me lock it. And then I'm going to draw a line, and I'm just going to draw a line right up here. And let me just move in. Great. Now, I know that this elevation is looking straight up to here because this is the highest point right up here. And if you look here, this is the highest point up here, 20.5 meters. And so I'll tell you what this plan is actually saying. But for now, I just want to make sure this is to scale. So if I draw a line, and let me see, just estimate right here, around here, and go up. If I type in 20M, Rhino knows that that's meters. Right, and let's go like that. So this is 20 meters. So we know that this drawing is not, I have to scale this drawing up. So let me go ahead and unlock it. Okay. And so I want to scale this drawing up so that this becomes 20 meters. So I just type in scale, right? And I can just start from the bottom right here, right? And I'll click here for my second reference point, right? Or I guess my first reference point. Like that, so right around there. Then let me move my mouse up, 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 boom. So now this drawing is true one-to-one scale. This is 20 meters right here, okay? So again, this is an elevation of this side right here. So I wanna draw a line that goes up from here. Let me just zoom in, just try to be, I'll do the center points of these intersections. And we go up like this, right? And then we go here. This is the end point of one of them, like that. Like this. Very good. So this right here this right here starts here like that, right? So I need to scale it like this. So I'm going to draw a line here so I can use that as a reference. Again, this course is geared towards like beginners and intermediates, right? So I want to do scale, and this is my, my origin right here. And this is perpendicular, and then I want to scale it perpendicular to that. Perfect. So now this drawing is perfectly to scale, okay? So now we're done with this. I don't need these guiding lines anymore. So I'm gonna rename this layer over here, and I'm gonna rename it as plan. Okay, and I like to work in a black background. You can work in any color that you prefer. Let me make sure these are locked. And so the first thing that I'm going to do is I'm gonna trace the plan. So these lines might look a little confusing, but I wanna explain what's going on here. Let me make sure nice, okay. So first off, the actual design itself is based off of hyperbolic paraboloids. Originally, like the actual original design was based off of like conoids, but it became too complex. So they wanted to design everything off of a consistent geometry, both in plan and in actual like three-dimensional massing. So they based everything off of a parabola. Even the plan you see here is based off of a parabola. So if you look here, for example, if you see these lines right here, and like for example, this line over here and this line over here, what it's saying is that this plan right here is based off of a parabola. You see? And then if I go here, you see, this is saying that's based off a parabola. Sorry, I'm not tracing it accurately, but same thing here. So you see this from here to here, that's a parabola. And then same thing from here to here, this is a parabola. You know, so parabola has a focus. This is the focus right here. That's the focus. That's the focus. That's the focus. That's the focus. Multiple focus to call foci. So this is one right here. So that's the first part. The other lines that you see are the actual structural members. They call them frames. They're concrete, pre-stressed concrete frames, cylindrical frames. And these are like the high points of each of the intersections. Okay. And so, you know, there's like three major high points that you have. We have a high point right here. You know, this is another high point here, another high point here. And then we have these intersections right here and right here. So we're going to go ahead, and the first thing we're going to do is just draw a very basic outline of this. We can use the parabola command, but to be honest, I'm just going to use the point curve command, the control point curve right here. So I click here, and let's just start. So I'll just start here at the center here, and right here, and right here. I can also do interpolate points, but I like to use this one because it's only like a 2-degree curve. You can do a 3-degree curve, but I just like this because it's very simple, not that many control points. We can make it very, very accurate, but this is more than enough. Same thing here. So I'll start here, and I'll go here. I'm only clicking at the inflection point. That's all I'm doing. So I go here, I'm dragging this with the gumball, and I'm just moving it like this. You see, pretty straightforward, you know? And then here as well. So again, control. You can also press enter to repeat the command. I can tell here that this is actually not a true, just on the drawing, it's not true because this also looks like an arc as well, but we're just gonna ignore that. In reality, this one should have 4 points. If we want to copy the actual shape of it, we should add another point here, to be honest, if we want to follow the actual plan itself, but this isn't accurate. I know for a fact that this should be more smooth because if it's a true parabola, it'll only have 3 points. You know, it'll have the vertex points and then the focus. And so this is, I don't think, an accurately drawn plan. If I go over to let me just slide over here, and I'm going to go through this documentation right here. But this is the true floor plan. This is like very clear documentation of the floor plan. This is the actual true floor plan. And so if you notice, you know, these are like true parabolas that you see here. It's not like a double or like 3 radii to the curve. Let me just go back. All right. If you want to follow the plan, just type in insert control point. And you can insert a control point right here and press enter, right? And then I can push this one down like this, and we can push. Again, I'm just using the gumball. That's all I'm doing. Like that. There you go. And then we'll do the exact same process over here. So control point curve, I'll just start here. Again, I'm clicking on the inflection points. That's all you really need to do when you do curves is click on the inflection points, which means the point where it's actually turning. So here, and let me go right here, actually. Like that. Okay, about this portion here, I know this is not accurate. This actual drawing is not accurate because if we go back to the original floor plan, you can tell that this isn't curving like this much. If we go here, do you see how this is way more grand, right? And this is more of a simple curvature right here. You see? So this right here, I guess is maybe like preliminary, like maybe right before the final, but this isn't accurate. This should actually go all the way probably across over here. But what I'll do is we'll just follow this as is, but with one minor modification. So let's do continue the command. We'll go here, start here, go here, go there like that. Let's pull that up like this. Nice. And then we'll do one right here. Pull that up like that. Nice. Okay. Boom. So now we have all of the actual points. Okay. So let me, or the actual base plan. The next thing we're going to do is do all the high points. So let me just make a new layer here and let me call them high points. And let me just make the color just a little bit lighter. And let me make it active. Okay. So I'll type in point. And again, I'm all in plan view. So like for sure, we know that this one here is 18.5. We'll go right here. We'll go here. We know that this point here is about 13 meters. And then we can go here. We know this is about 20 meters. And then this is one of the intersections. And then this is also one of the intersections. And then this is one of the intersections right here. I'm going to ignore this. Let's just start with these for now. So this one here, let's go to perspective view. I'm going to hold Alt and duplicate it upward, and I'm going to go 18.5 meters upwards, right? So that point is up there, right? I'm going to go click on this point. I'm going to go up 13 meters. I'm duplicating these. I'm going to do this point here, and I'm going to go up 20.5 meters. Perfect. Okay. So let's just work with these 3 points for now. Okay. So the first thing that we can do is we can draw like the major connections of these points, right? So for example, let me make a new layer here, rename it, and we'll call them frames. Okay. Let's make this active now. And we just change colors. Cool. So if I do a line, I don't want to do a polygon, just a regular line. I'll start from this point. I'll go here like this. You see? And I can click on this, right? And we know that this one connects up to here like that, right? And we can go here, and we know this connects like that. You see? And if you need to look at photographs, it's good to look at photographs. If I go, here, I can start looking at photographs, to really understand the references. So the next thing we're going to do is now we can connect. This goes here, right? So if we draw a line, this will go here like this, right? This is the entrance, right? It goes in like that. And then same thing over here, right? So I'll draw a line. This line goes up here like this. This line will go in like that, right? We have this line here that will go. So if you see this line goes all the way here like that, right? And so if we see right here, right, this line connects to this point here, right? So if I go to my top view, if I do point, right, like right there, right? Then I can draw a line from here to here like that. You see? So it'll be like that. So if we go back to that photograph that we were just looking at, it was looking like this. Let me show you. So that's this photograph right here. You see, it's this line going down like this, and then you have this line here. That was that photograph. there's actually you can't see it, but there's actually another frame right there. That's exactly what this is right here. You see? Great. Now here, there's a point here that's important. This is the 8-meter point, and there's a point here, and there's a 9-meter point, right? So if I draw a line and I go up 9 meters, right? And there's a point here, I'm gonna go up. This one is 8 meters. Okay, so we have something like this, right? So in reality, this line goes from here to here, like that. And if I extend it all the way through, it should technically hit this, but because, it's not like 100% accurate, I can just take it and just move it here, right? And so what's happening is you see this line right here. Let's go to top view. And so this line right here, right, is going to go, and it's going to go all the way right here. You see? So we'll draw a line. From this point, it's going to hit that point, but in reality, we'll just go like right here, like this. So let's go back to perspective, see what's going on. Right? Now, we know for sure that this line goes like this to this, right? And then this line goes from here to here, like this. So let's go back and look at the references for this space here. If we go here, this one comes and it hits this point here, right? So it goes more like this comes here, connects there, and that hits to this intersecting point right here, right? So let's go back. So we have a line. This will go from this point here, right? It goes from this point here, and it goes to this point right here. You see? And then this will go from here to right here, like that. And that's basically it. Like these are the actual these are the actual structural frame members of the design. So now the next thing that we want to do is actually do like the actual surfaces of these. And there's a lot of ways of doing the surfaces, and I'll show you the multiple ways of doing them. But let's first work on the hyperbolic paraboloids that are like pure rectangular. They're not curved, right? So let's start right here. So let's rename this as surfaces. Make it active. So like, for example, we'll do the perimeter ones last, but then we'll come back and do the, but we'll first do the rectangular paraboloids and then the final curved outlines last. So let me turn off the high points. So the first one that we're going to do is probably sweep 2. We'll do this one first right here, right? So what I can do is, let me draw a separate line. I can split this line, but I don't want to do that for now. Let me just draw a line from here to here. Okay. And then let's do sweep 2. So if I do sweep 2, I'll use this as my rail 1, rail 2, sweep shape 1, sweep shape 2. And then I don't want to change the cross sections, and I want to refit the rails so that it's twisting correctly, you know? And then I'll do okay. And so we get this, right? Just get rid of this piece right here. I don't want this curve. Nice. So the next one that we're going to do is here is this one here. And there's a lot of ways. We can also do the sweep too. You can sometimes use this one, the surface from 3 to 4 points. I'll show you. So we click that over there. And then I can click on this point. You have to do it in order though, because that's how it's going to connect the surface. Here. And then here. You see? Sometimes I won't do it because the tolerance is too much. If I do rebuild, I just want to see what kind of surface. Yes, it's a 3 degree. Let's just do 3. Yeah, it's a 3 degree surface, right? I think this is too sharp to do the surface from 3 to 4 points. We'd have to do the sweep 2 again. So let's just do sweep 2. And we can use this and this as the rail. And then we can use this and this as the sweep shapes. Enter. Okay. Beautiful. Yeah. So basically, these are all of the hyperbolic paraboloids that are not curved at the base. These are just basically like some type of rectilinear in plan. You see. So now the curvature ones, there's a lot of ways of doing this. One way is network surface. The other way is, again, sweep 2. But I like the sweep commands because that's the most accurate. But let me just show you network surface. So if I do network surface, it'll say select curves on network. You have to select a very specific order, right? So like I can select this, excuse me, this curve right here, this curve right here, and then this curve right here. You see? And I press enter, right? It'll average it out for me. And you can decide the tolerance level, right? It'll decide it. So if you make it like 0.01, this is going to change. Take a look. You see? 21. If I make it 0.1, you see? And so what that means is that it's going to deviate. The surface is going to deviate a little bit from the actual edge curves. That's what's going to happen. So like A, B, C, you see and this is how you match the edge. There's like very specific definition for these. You can decide between this and this. If you make it loose, it's going to be more like continuous, but not as accurate to the edge matching. So that's network surface, and you can make a very, very tight tolerance, but it's going to increase, it's going to increase the actual memory and like the actual size of your file because you're adding more data to make it more and more accurate. The other way we can do sweep 2, right? And select this as my rail and select this as my second rail, right? And then select this as my sweep shape and press enter like that. That's the other option. And you can rebuild it as well if you wanted to. Do okay. You see? And so we'll do the same thing here, right? So this one right here, we can do the sweep 2 command as well. And so if we do, but again, I want to have this as a separate line. Right now, this is one big line going across. I don't want that. I'm going to draw a separate line just for this. So if I go here and here, right? If I do sweep 2, I want this to be my first rail. I want this to be my second rail. This is a sweep shape. And then I want this to be a sweep shape right here. Enter. Oops, I clicked on the wrong one. Excuse me, do that again. Sweep 2, first rail, second rail, sweep shape. I didn't see that. Sweep shape. There we go. Okay. You see? It's coming together. It's very simple. When you break it down into a very basic geometry, and honestly, this is a very important thing to understand about Rhino and modeling complex geometry. You want to break things down to its most simple form to understand how the geometry is generated. And that's typically through like points and lines, and then it'll expand to planes. But that's how you break down something that's so complex, something as complex as this, right? You want to break it down to just very basic lines, to a very basic framework, and then work your way up to something more complex, and it'll help you understand it. And in real life, like when it comes to the geometry or the construction of this, they needed to simplify the geometry to make it more constructible. From before, if you read the history of this, it was actually more complex than this. But there was this give and take with the structural engineers of how to make this more simple, and that's why they switched to like a hyperbolic paraboloid, where all of the lines are like literally all of these tension cables that you see here are straight. All right, great. So now here, again, we're going to do sweep 2, but I want to make sure this is a line set because this is the continuous line. Let me just draw a line here. So I do sweep 2, first rail, second rail, right here. And this is my sweep shape. Right? And then we have this right here. So sweep 2. Okay, and so for the last portion, it's going to be on this side over here. And so again, we're going to do the sweep 2. We're going to sweep, these are going to be the rails, and this is the cross-section curve right here. So just sweep 2, and first rail, second rail, and this is the cross-section. This. So let's go ahead and do, again, sweep 2 for this one. And so this right here is going to be the first rail, and this right here is going to be the second rail. And then these two will be the sweep shape. So sweep 2, first rail, second rail, and then sweep shape 1, sweep shape 2, enter. There you go. It's nice and smooth. And that's basically it. I mean, this is the actual pavilion with all the surfaces. So I actually have the real photographs that you've been looking at and that I've been referencing. I just didn't want to have it in the Rhino model in the modeling portion because I didn't want it to be distracting. Just wanted to focus on the Rhino commands. And so we'll just do a comparison of our actual surface creation on here with the real life photographs of the actual pavilion. So let me just zoom out. It's all the way over here. Bring them over here. So right here, this is actually a great shot right here. So this is like kind of looking aerial, So if we look at it, just so, I mean, this is like an old photograph. This is probably like 35 millimeter. Let me just change the camera angle to 35. And so let's see, it's more biased to the left, of course. And this is, I mean, honestly, this is a pretty good angle. So the next thing that we're going to do is the actual structural frames, as they call them. And so they're 400 centimeter diameter pre-stressed concrete frames. And so we're just going to use the pipe command, and it's very straightforward. So I'll probably fast forward it after I show a couple of commands. So let me just rename this layer. We'll call it piped frame. And then we just give it a color. Do this one. Okay, great. We'll make it active. So here, like for example, this here, I can I want to pipe these two together, for example. I can do pipe, and then I want to make sure the cap is round, right? And then for diameter, I want to do 40 centimeters, not 400. Excuse me. I think I said 400. It's 40 centimeters. So enter like this. Perfect. And then the same thing here. I like to do, probably two or three at the same time so that they can connect them like this. So let me just repeat the command, and then I can just press enter to repeat everything like this. And then same thing here. So it's pretty straightforward. I think there's a longer version of this. Yeah, nice. Let me do this one, and this one. There we go, nice, like that. This one can be done by itself, like that. Great, so I'll just go ahead and fast forward through this and show you the end results. And so I can show you, I'm going to show you in Rhino how you can create this very simple way. Like it's like a shortcut. Instead of using Grasshopper, you can use it in Rhino. Very easy way of doing this. So I'm going to show you how to actually create these. It's actually really, really easy. So go to shaded view. If I go here and first off, to get these guiding lines, right? I'm going to make a duplicate of these surfaces a couple times. So let's do this. I'm going to go to layer, surfaces, select objects. And I'm going to isolate this for now. Okay. So I'm going to select this whole thing and I'm going to do Control C, Control C, Control V. And let me just move it here. Okay. I want to show you something. So I can get the framework of these. If I click on this and I type in rebuild, okay. Sorry, we'll do one surface at a time. So let's do this surface. I'm gonna rebuild the surface. This is a silly way of doing it, but it's a very fast way of getting the framework. I can rebuild this for the point count and get do 20 by 20. You see? And I can get all of this right here. I can do the same thing right here. Okay. So I'm rebuilding the point count on here. This makes the file very heavy, by the way, but the reason why I want to do that is so that I can split these surfaces, okay? That's number one. Wireframe. And so I'll just select this whole thing, enter. So now I've extracted the wireframe of everything on here, you see? And let me just group it right away. There we go. So if I select this, you see? Now let me just duplicate it. That's the actual wireframe of the project. And so I can go ahead and I can split this entire thing. So we just save this file because it might crash. If I do split, right, select objects to split, I'm going to split this. Let me just deselect. Actually, let me do this. Let me put this on a new layer. Call it WF for wireframe. Let me just change its color. So let's do split. And then Sorry, I'm gonna do that again. Let me turn this. Let me just go here. Split. Let me turn this off. I want to split that. And then the cutting objects is this, select objects. So it's going to split everything. So everything's been split right now. So if you look here, everything's a panel now. So we can give all these the thicknesses if I wanted to. I mean, it got a little crazy over here, but it's okay. If you do it individually, it won't go crazy. Let me just hide that. Okay. So what I can also do is I can do the cables, right? But I want to offset these off. So look, I'll just do the outside cables. So if I do offset, let's do, sorry, offset surface. And I'll just do like maybe these right here. Well, I'll do all of them to be honest, because I think they'll go all in the same direction. We'll see. We don't want it solid. And distance, we want to offset them out. Let me see. See, some of them are going in different directions, which I don't like. I want them to go all in the same direction. Like this one's going in, but that one's going out. So let's do this. Let's offset. Let me just do a couple. Let me do these two. Yeah, because these are going. So let me do after flip. I do not want it solid. Let me offset it out like 6 centimeters. Awesome. And then I will go ahead and rebuild this, right? Exact same thing. Rebuild that. And then I'm going to do extract wireframe. Of this one and this one. Group it. So I don't want this anymore. I just want the wireframe. I want these wires. That's all I want. And so the same thing here. I'll just offset surface. Let me go ahead and offset. See if they all go in the same direction. No, you see how this one's going. These two are going in, that's going out. Let me do these two. Very troublesome. I guess I'll do one by one. And then I'll rebuild. I might fast forward through this, but extract wireframe. Group it. I'm just going to go ahead and hide these. I don't need these anymore. Beautiful. So I could offset surface these to make these actual surface thicknesses. We can save that for later, but like for example, I do offset surface, right? Flip it, right? I can give it a thickness. Or I can do both sides. I can make it solid. I can do both sides and do, since it's only a 5 centimeter panel, 2.5 centimeters for both sides. And so you see, it has a thickness now. if you make a really cool diagram, you can do that. And so you would just put that in here and overlap it. So let me just turn on. Oh, I got to unisolate. You know, and then if I take this and these right here, let me just group these. I can pipe these. You know, I can pipe all of this and give it a very small diameter. So I can pipe. Let me just put it on frames layer or wireframe. Let me make a new layer. I'm sorry. We'll call this tension cables. And then let me just go ahead and pipe these and give it a diameter of like 0.25 inches. This might take up a lot of memory because I'm piping like hundreds. Oh, okay, never mind. But I think I piped it in the wrong layer. It's okay though. You see? And let me go here and let me just isolate. Put it rendered. There's a couple things on here that people aren't aware of about this design. First off, this whole thing's made out of concrete and steel cables. That's number one. And so these panels here are made out of concrete panels. So let me just go here. Let me just this is from the MIT library. This is the actual Philips did like an actual technical review of the entire project from start to finish. And so it's from the MIT library. It's a fantastic, and it's for free. If you search it up, it's all for free. This goes into complete detail from the structure to the design to the acoustics to everything. It's actually a really fun read. And so if you go down here to the construction, let me just show you. And these are like all of the design iterations that they went through, you know? So like this is like the first pass of this one here. Like originally they did some like complex geometry and they had to simplify it for the structure to be more buildable, you know? So they did things so that all these lines are straight. These are all straight lines. Like, yeah, it looks like it's twisting, but it's actually, they're parallel to the surface. And this is like a very rudimentary, I guess, representation of a hyperbolic paraboloid. And so here, you see here, I guess they're called hyperbolas right here. Everything in the plan is a hyperbola. So again, so much great documentation. So this is the inside of it. You see, it's pre-stressed concrete, but it's a little. The term is a little tricky, and I'll tell you why. It goes into a lot of detail of the construction, or I guess the structural analysis. But I just want to show you how they actually built it. So this is all the testing. They did like 1 to 10 scale model testing. They first did like plywood panels and plaster models and stuff like that. This is the cool part. So this is like a simple diagram of pre-stressed concrete. You see like where they put this is like a concrete beam, for example. And what they're doing here is they have a tension cable that's literally in the shape of a parabola. And it's tensed, it's pulled, it's very tight. And so before there's any loading, all the tension's on the bottom, right? And then once you put a load, because this entire beam is already in tension, the whole beam is before the load is already in tension. So the entire load becomes compression. The beam never experiences tension if you're putting a full load on there. It'll just reach equilibrium, and obviously it's like a very, very strong beam. So if you surpass it, you're not going to surpass it because that will be a point of failure. But basically, this beam already is like, if you drew like a moment diagram, this beam is like already has like a positive moment, right? So when you add a load to it, the moment just gets less and less and less and less. It never has a negative moment. That's what's so beautiful about pre-stressed concrete is that all of the load is happening on the very top. All loads happen basically like above the centroid or above like the central axis. Nothing's happening on the bottom. And so if you actually look like at a pre-stressed concrete beam, for example, it has like a very like slight, I guess, camber. I'm not sure if that's the correct term, but it has like a slight arch to it already because it's being pulled so tight. It's awesome. It's a very cool way of constructing concrete. And so what they did here is that they made the actual diaphragm of the design. They made it out of they made the molding out of sand or loam right here. And so what they did is they actually poured the concrete into these panels right here. And so each of the panels, this is literally the shape of each of the facade of the pavilion. You see? And like it's very and so that's why the geometry had to be simple because then you're using these. This is like wood forms, right? And then these are the ruling lines. So everything needed to be straight. Super cool. I mean, I think pavilions are like the best examples of testing novel methods of construction and usage of materials. And so right here is where they poured all the concrete. And then they'll ship it off to the site, And then, okay, so this is them doing the actual construction over here, right? So this right here is the actual concrete beam. I'll get into that later. And then this is just all of the it's formwork for the panels. It's not like they're not pouring concrete anywhere. Only for the columns they pour concrete, but everywhere else they're just laying out the panels. So these are the panels that they made in the sand form. You see? And then they'll just mortar the joints right here. And then, this is the wood beam formwork that they're using just, to hold it in place. And then this is like the concrete footing right here. And then these are the pre-tension rods that they have in here. And I'll go into detail about that. But yeah, this is the facade right here. And so let's go into, okay, this is a great diagram. So basically right here, right, you have your footing. So this right here, right, is you can't see the underground portion. What you're seeing here is the above ground right here. This is what you're seeing, right? So let me this thing is this thing right here, right? And then this thing right here is this right here. And then this right here are the cables that are sticking out right here. And then this right here, right, is that panel you saw on the previous page. It's this panel right here. And so you have these cables that will come out and then they add tension to it. And the whole thing is in tension. The entire pavilion is in tension. The whole thing squeezed together in tension. So the only thing so that means that the actual pavilion will never experience a tensile load because it's already in tension. It can only experience compressive loads. I mean, don't quote me on that, but like the whole thing is already in tension. So like when a load is impacting the actual structure itself, it's not going to experience more tension. You know what I'm saying? Because there's already tension onto it. And then this right here, you don't see it right now, but like what they do is they needed to everything is pre-stressed, even the footing's pre-stressed. So like they needed to add these little like wood blocks that went across here, right? And then they would pre-stress the actual cable that you don't see anymore underneath the footing. So let me go down here. And I'll show you other pictures as well. But you see here, do you have these? Let me zoom in. Hope I can zoom in on this. See that's the pre-tension rods right here, and they're both on the inside and in the outside of the pavilion, and it's anchored into these 40-centimeter pipe frames, which are not pipe, they're concrete, pre-stressed concrete. And you'll see that next page. So right here, you see. So this is the only concrete formwork they did on site. Was this? So this is the concrete formwork they did on site, and it's also pre-stressed. And they pre-stressed the cables in multiple axes, not just straight. And this is a great diagram. This is an awesome. This is a cool photo too, showing them how they're tensioning the cables. So Again, what's not accurate about this is that they also have tension on the inside as well. It's not just one cable; it's two cables on the exterior and the interior. And so basically, this is already preset into the column, and then this is the actual cable that crimps into it, right? It ties into it, and then these are the actual workers itself. They're literally tightening the building. They're literally tightening the entire design into these columns. That's literally what everything's being tightened in. So everything's in tension. You see? So this is the final one. There's better photos, but it's such a cool way to test out. I mean, this is done in the 50s. There's other architects that do like awesome work like this back in the mid-century. There's I forget. I think it's Luis Nervi. He's Italian, I think. Beautiful concrete shell structures, and then obviously there's Felix Candela in Mexico. He does, and in America, he did work in America as well. Awesome work as well to check out. Again, this is absolutely for free. If you Google this, and I could put the links on here, you'll see it. And then let me just go to the photographs because see, this is a great example of seeing the tensioning rods. You see? So let me just click on it and zoom in. So you see, this is all you see. Everything's being tied in. And then let me go here. This is also a great photo. And then this is a really nice. This is like basically like after construction. I think like this super clean construction. This is actually a better photo to match, but and so these are. Let me just pay attention. These are the grout lines of the panels of the concrete panels, and so the majority of the cables are following the guiding lines of the actual panels, but some of them go against it. Let me zoom out. Like for example, this one here, you see these are kind of going against it. But yeah, so these are 40 centimeter frames. This one actually really matches the other photograph didn't do a good job, but this one really matches it. This is awesome. And so you can tell if you look here, it's also tension on the inside as well. It's tight on the inside, both inside outside. Again, let me just give credit, make sure people are getting credit. So this image here. But hopefully you found this helpful. If you have any questions or comments, or if you like the video, just please please leave in the comment section below, and please subscribe and like if you found this helpful, so you can help the channel grow. Yeah, thank you.